is the last problem from the first section, the previous section, where we have to simplify. In order to add or subtract, we have to simplify the radicals before and look for like terms because we're adding. So, cube roots. Cube root of 125, again, looking in our table, 125 is here. Cube root of 125 is 5. So this is going to be 5. Cube root of 125 is 5, so it's going to go out. It's 5. And cube root of x. Then 64. 64 is another perfect cube root. 64, cube root of 64 is 4. So we're going to have 5 times 4. This is this one. And cube root of x. So we have to multiply these two. We have 5 times 5 is 25. Cube root of x. Plus 5 times 4 is 20. Cube root of x. Like terms. Cube root of x, cube root of x. So 20 plus 25 is 45. So the answer is going to be 45 cube root of x. Don't forget to highlight. That was the last problem from the previous set where we have to add or subtract. The next problem, we have number 16 through 20. We're multiplying here. Multiply and assume, again, all the variables are non-negative, so don't use bars for the absolute values. Number 16, multiply. Let me just separate this. Multiply. We're using the rules. We covered this in class to multiply. We're using the rule, this one, when you're multiplying two radicals with the same index, you put them under the same index, and if we're dividing, we do the same thing. If they have the same index, you just divide, you divide these two with the same index, you put the same index again, and the division completely inside of the radical. So we're going to be using those rules in this. Like I said, this is not a new concept for you. We did it in class. We also did the homework. So you have enough practice to answer these problems. Number 16. Multiply cube root of x times cube root of x to the 8th. Since you have the same index, the rule says it's okay to write down everything inside of the radical. So when you multiply these two, you obtain x to the 9th. Cube root of x to the 9th is perfect. 9 over 3 is 3, so the answer is 6 cubed. Number 17. This one is square root of 3x cubed times 3x to the 5th power. What we're doing in class is multiplying first and then simplifying. Since the multiplication is possible because these two indexes are the same, so we're going to have 3 times 3 is 9. So we have 9. X to the 3rd times x to the 5th. You add the exponents, is x to the 8th. And then we'll go, square root of 9 is 3. 8 over 2 is 4. So it's 3x to the 4th, the answer of this problem. Number 18. We have cube root of x y to the 5th power times cube root of x to the 16th y to the 20th. Okay, same again, same index. Okay, open a big radical, index 3. So x times x to the 16 is x to the 17. Y to the 5th times y to the 20 is y to the 25. Now try to get cube root of this. Since 17 is not divisible by 3, 25 is not divisible by 3, we have to break down those two. And the more convenient factors are x to the 15 times x to the 2nd power, because the second one that is going to stay inside has to be less than 3. So the combination is 15 and 2. And for this one, repeat the process, is y to the 24th divisible by 3 times y. So I'm going to rewrite this as cube root of x to the 15th y to the 24th times what is going to stay inside is going to be x squared y. Why? Because this is 2 is less than 3, 1 is less than 3, that's why. Now we're going to continue with the answer. This is going to be 15 over 3 is 5, so it's x to the 5th power. 24 over 3 is 8, so it's y to the 8th. Cube root of x squared y. That's number 18. Number 19. This one is 5th root of x squared z cubed times 5th root of x 13 z to the 24th. So put everything on the same radical. This is 5th root. X 2 plus 13 is 15. Z 3 plus 24 is 27. Since we have to divide it by 5, 15 divisible by 5, perfect. But 27 is not divisible by 5, so we have to break down just z. So z is going to be broken into z to the 25th to be divisible by 5, z to the 2nd power. So this is going to be, we'll continue here, 5th root of x to the 15th power, z to the 25, times z squared. This is the only one that's going to stay inside. The rest of the stuff goes out. The answer is going to be 15 over 5 is 3, x cubed, z, 25 over 5 is 5, and cube 5th root of z squared. That's number 4. That's number 19. One more. Let me solve number 20. Is the last problem in this set. So I'm going to erase this part on the top to do number 20 here. Okay, number 20. Number 20 is multiply cube root of x times cube root of x squared minus cube root of 162 x to the 2nd power. If you notice, this is multiplying this factor times this difference. So what we're actually doing is, I want you to think about this reciprocal property when we are doing a times b minus c. A times b, ab. A times c, ac, minus in the middle. It's exactly the same thing. A, b minus c. So we're going to distribute this one into this difference. So this, just think about these two factors. This is cube root. So it's cube root of x to the 3rd power. This and this is going to be cube root of x. 1 plus 2 is 3. We're done with the first part. The second part is this one. So don't look at that. Just these two factors. Cube root again. So minus cube root of 162 x times x squared is x cubed. If we look for 162 inside the cube root, is not here. This is 125, and then the next one is 216. So it's not perfect. So but we need to break down 162 in two factors. So one of them has perfect cube root. Those are going to be, after you divide 162 by each one of this one, you're going to find out that 162 is 27 times 6. So this one is 27 times 6. That one I'm going to leave it as it is because it's perfect. So I'm going to rewrite this as a 27 x cubed. Inside of the radical is staying just 6. Continue. Cube root of 27 is 3. Cube root of x cubed is x. Inside is just a 6 inside of the cube root. And that's the answer for number 20.